All right, Robin, so we briefly highlighted the key features of Python, but there's so much more. We really didn't talk about the language constructs. So now we are going to talk about some of the most important language features and constructs of Python. Now, since this module is introducing Python, we'll try to keep it brief for you. The details of the language will be covered in subsequent modules.
So, as we've mentioned, Python is easy to learn.
Oh, yeah.
It is a beginner's language having relatively few keywords and a simple structure. And moreover, it has a clearly defined syntax. It will not take long for programmers to learn and start writing programs using Python. So one of the key success factors for Python is that its source code is quite easy to maintain.
True.
This means that the program meets your current needs by updating it suitably, and it may be by someone else. Python code is extremely easy to understand and maintain.
Absolutely, yeah. And Python is what we call a minimalistic language. People call it a pseudocode natural language. And this is yet another strength, really, of Python. Rather than worrying about language and syntax and the nitty-gritty of all the language things that drive us all crazy, it helps us to concentrate on the solution to the problem.
Right.
It doesn't get in our way, and that makes it simple, and Python really is.
You know, Python really is a classic example of a free Libre open source software, or FLOSS. So I'll explain.
All right.
You can freely distribute copies of this software. You can obtain and read its source code, and you can make changes to it. You can use it in other programs. So FLOSS is based on the concept of a community which shares knowledge. This is also a reason why Python is widely used. And there are both 32 and 64-bit versions for most operating systems.
Great. And Python supports procedure-oriented programming as well as object-oriented programming. So what does that mean? What's the difference there?
Tell us, Jeff.
Well, I will. Most programmers in their early weeks or months of programming life try to figure out what these really are. They find it a little difficult to switch between the thought processes behind these. So in procedure-oriented programming, the programs are built around procedures or functions. Pretty self-explanatory. These are nothing but reusable pieces of programs. This is how you modularize the code. You make it readable and easy to maintain.
Yes.
Now, however, in an object-oriented approach, the program is built around objects, right, which combine data and functionality. Python is very powerful in this approach. However, it has a simpler way to implement it in comparison to other languages such as C or C++ and even Java.
Now, Python is dynamically typed. So this is the same as Perl. It means that variables do not need to be declared as real, integer, string, etc. at first. You can start using them straight away, unless you have a reason to define them earlier. The type of variable is automatically defined by the value assigned to it. So the value decides the type of variable. The type decides the operations you can perform on a variable. These are primarily decided at runtime, as Python is an interpreted language, and it doesn't have an executable version.
Exactly right. And if Python is a dynamic type language, what are static typed languages? Kind of begs the question. Well, you have veteran languages such as Fortran and C. They have the data types defined up front, and they have an executable, as you know. The type and the operations are decided at compile time. Python has an extensible feature. You can import modules from other languages into Python. You don't need to redevelop the code in Python if there is already a piece of code available in another language and if it can be imported. Super flexible and easy to use.
Very cool.
Yeah.
So it's not only extensible. In fact, you can embed Python codes in C and C++ programs to provide better scripting capabilities there. So Python has a huge standard library. And the library contains many packages that can help us to do various things involving regular expressions, databases, documentation, generation, and other system-dependent stuff.
Right. And in addition, Python is also portable. Its open source nature is really its biggest strength. Generally, Python programs can work on any platform without requiring us to make any changes. Makes it very scalable that way. And you can port Python programs with Linux, Windows, Mac OS, OS2, Solaris, even PlayStation, Windows CE, Pocket PC, the list goes on.
Yes, and we keep saying that Python is an interpreted programming language. Well, we also briefly mentioned some of the differences from other languages. So you may ask, what is the difference between an interpreted language and a compiled language? Well, languages such as Fortran, C, and C++ are compiled languages. So this means the entire source code file is read and then converted into an executable code or machine-level language. This executable will have many operating system or platform-dependent instructions, which may not work on other operating systems or platforms.
Okay. Yeah.
Data types and operations on them are decided up front, and it can be executed directly on this particular operating system.
Right. And now, on the other hand, in an interpreted language, the source code text file is read line by line, and each statement is converted into machine language and then executed before the next line is read. There's a little difference there.
Right.
There are no two steps of compilation and execution. In the case of compiled languages, it is compiled once and used multiple times. In interpreted languages, the programs are converted each time you run it. So generally, compiled languages are more efficient and faster because you don't need to go through the hassle of converting the code to language machine or machine language. It comes already in machine language and in most cases in optimized form. However, interpreted languages, they're actually more flexible and changes can be easily done to the program at runtime.
Now, having seen some of the key features of Python, let's see what's new in Python 3.4.
Okay, let's do it.
So we're going to start with the bootstrapping of pip in Python applications. The new ensure pip module provides a regular cross-platform mechanism to bootstrap the pip installer into Python installations in virtual environments. Now, note that I said virtual environments. Python is not lagging behind the rest of the IT world in terms of adapting the latest technological developments.
That's nice.
Commands such as pipx and pipxy normally come with the Python package. Now here, xy denotes the version of the Python installation.
In Python 3.4, the documentation has been reframed for installing and distributing Python modules. This work is still in progress and legacy versions are still available. But let me talk about the next key change, all right?
Okay.
Newly created file descriptors are now non-inheritable in Python 3.4. This is what an application would like to have when you launch a new process. Allowing currently open files to continue to be open when a new process is launched can lead to bugs, which programmers hate, and they may find them difficult to locate, right?
Yep.
So, however, this cannot be made mandatory. Now, there are cases where you want the inheritance to work. Python 3.4 provides new functions to handle this by making use of the following functions and methods. Are you ready?
I'm ready.
os.get_inheritable, os.set_inheritable, os.get_handle_inheritable, os.set_handle_inheritable, socket.socket.get_inheritable, and socket.socket.set_inheritable.
There are improvements to codec handling. So type-neutral dynamic encoding and decoding systems are intentionally operated by the codecs module. The codecs.encode and codecs.decode functions are listed out in documentations of Python's earlier versions.
Right.
So in the codecs module, these functions have been in use since Python 2.4. And in earlier versions, they're discovered only through runtime inspection.
Now, there is a module spec type for the import system. Import implementation as well as import linked APIs are simplified using module spec type. This transformation creates a way in for several import-related improvements in the future. Backward compatibility is a predominant problem that developers face. Those types are transparent. This may not be true for importer authors. Some methods such as key finder and loader are removed, but they still work. Importers who are new can use the new methods that are described in PEP, while existing importers can upgrade to implement the latest methods.